We are going to look at example number 3, equations with one root, and we're being asked to solve and verify the following equation. This is the first time that we have been forced to factor by decomposition, and so I'm going to go through it fairly quickly, and I will post a link to a number of Khan Academy videos on factoring. They call it factoring by grouping. I refer to it as factoring by decomposition. So when we're in a situation where in front of our 4, or in front of our x squared term, our a component or a parameter is no longer 1 but another number. When that happens, we need to take this 4 and multiply it by the 49. We multiply those two together. When we do that, it gives us the number, and which is in this case 196, and we want to get two numbers that are going to multiply to 196. And so in the Khan Academy, they would say A times B would give us that. And the second piece is the same. We're looking for two numbers, A and B, so A plus B, right? In this case, they need to add and give us 28. I can see for myself, these numbers, what are those two numbers? They don't pop out at me really easily, and so I'm going to use my factor tree. I use 196, and I know that 1 and 196 are going to multiply to give me 196, but if I add them, that gives me 197, and clearly that's not going to work. Then I go on to 2, and I ask myself, is this divisible by 2? And because it's an even number, it's divisible by 2, and so we would take and divide 196 by 2, which gives us 83, and when we add those together, it's 85, so clearly that's not what we're looking for. We check if it's divisible by 3. You can work it out on your calculator, or you can use the divisibility rule, and we find, no, can't be divided by 3. Check out 4. Well, of course it can be divided by 4 because we created it by multiplying 49 by 4. So 4 times 49 gives us 196, and when we add these together, oh, we get 100, or we get 53. So we're still not adding to get 28. We check out 5. Is it divisible by 5? No, not divisible by 5 because it doesn't end in a 5. We go to 6. Well, if it's not divisible by 3, it can't be divisible by 6. And we continue on. And you would continue on until you reached 14 and 14. 14 times 14 gives us 196, and 14 plus 14 gives us 28. And so now that we have those two numbers, what we do is take this middle term and separate it or split it into two terms that add to give 28. So 14x plus 14x. And we have plus 49 behind in the end, and in front we have 4 times x squared. And all of this is equal to 0. So we have decomposed this middle term into two terms that would combine to give us that middle term. That's why it's called decomposition. Now, the other reason why it could be called grouping is because we group these two together. The first two get grouped, and the second two get grouped. We then look inside of that, the first binomial, and see, do we have a common factor? And in fact, we want the greatest common factor. And our greatest common factor is 2x, and that leaves us with 2x plus 7. So when we factor the 2x out, we're left with 2x plus 7. Then we go and we make sure we bring this addition symbol down. We're adding these two, and we have 4x minus 49. Again, we're looking for our greatest common factor, and that's going to be 7. And when we factor the 7 out, we're left with 2x plus 7. And all of that equals 0. Now, when we're factoring by decomposition or by grouping, we know that we've done it correctly when our two binomials that remain are identical. So we can factor those two, the binomial out, 2x plus 7, and when we do that, in this case, we're left with 2x plus 7 because we factored the 2x plus 7 out. So here we have 2x plus 7 times 2x plus 7 equaling 0. Notice that our two factors are identical. When they're identical, this means that we have only one root. And we can determine that root by setting the factor 2x plus 7 equal to 0. We move the 7 across, and we do that by subtracting 7 from both sides. We're left with 2x is equal to negative 7. Divide both sides by 2, and we're left with x is equal to negative 3.5. We're going to do a left side, right side verification. Our right side is 0, and our left side is 4x squared plus 28x plus 49. And we substitute in the value that we believe to be the root of the equation, negative 3.5 squared. And we square it here, so 4 times negative 3.5 squared plus 28 times negative 3.5 plus 49. So we pull out our calculator and we go, okay, 4 times. And remember, when we square a negative, we want to make sure that we put it inside the brackets. So we have negative 3.5 inside the brackets, all squared, plus 28 times negative 3.5 plus 49. Press enter, and we get 0. So our left side equals the right side, which means the solution, or the root, and that is example number 3.